Hello, today I am going to discuss about the PLC input output wiring to external instrument sensor or switch as well as external load. Okay, before we go into detail about this topic, let me talk about briefly regarding the syncing and sourcing of the PLC. Actually, I have a video that talk about this syncing and sourcing concept. If you are really interested, please refer to my previous video. I will only talk briefly about the syncing and sourcing of PLC since it is related to our topic of discussion on today. Okay, so this picture show the PLC in syncing and the PLC in sourcing mode. Okay, so for this picture, that this PLC discrete input card act as a syncing. As for this picture, it shows that this PLC act as a sourcing. So for this PLC that act as a syncing, the external device will act as a sourcing. So it must be always opposite to each other between the external device and the PLC. Okay, as for this PLC that acts as a sourcing, the external device must act as a syncing. Okay, for this PLC that acts as a syncing, the external device will act as a sourcing. Sourcing means it connects to the power supply. So this positive polarity of the DC power supply will be connected to this instrument limit switch. And the current will flow through here through the limit switch to source the limit switch and then will flow through this terminal to sync the PLC digital input load to the common line. Okay, and then back to the negative polarity of the power supply. As for the PLC that act as a sourcing, okay, as I say, sourcing means connected to the power supply. So the polarity, the positive polarity of the DC power supply will be connected to the DC voltage terminal of the PLC so that it will source the PLC digital input card load, and then the current will flow out from this terminal point to the limit switch to sync the limit switch to the negative polarity of the DC power supply. Okay, as for the PLC wiring circuit, no matter which circuit it is, whether it is a PLC digital or analog input circuit or the PLC digital or analog output circuit, the circuit must has at least one load. Okay, this is important. I emphasize again. No matter which circuit, whether it is a digital or analog input or output circuit, no matter how complicated the circuit is, the circuit must at least has one load. Okay, it can has more than one load, but at minimum it must has a one load. Why? Because if a circuit without any load, this circuit will have very low resistance and can cause short circuit, and it may catch fire also. So this is important. Okay, for this PLC circuit, you can see PLC circuit has at least one power supply, okay, one external device, whether it is a instrument sensor or switch or external load, and then one load, okay, and this one also one load. Okay, for the PLC input card, whether it's a digital input card or analog input card, okay, it has the internal load inside the input card. Okay, as for the PLC output card, whether it's a digital or analog output card, it do not has an internal load. However, it have a switch, whether it is a solid state switch or any other type of switch. Okay, so this is the difference between the PLC input card and the PLC output card. Okay, as I mentioned earlier, for any circuit it must has at least one load. Okay, since the PLC input card already has an internal load inside the input card, whether it's a digital or analog input card. So the external circuit will be connected to the switch or sensor, and also a power supply. Okay, we need a power supply to flow the current signal to the circuit. Okay, as for the PLC output card, whether it's a digital analog, since there is no internal load inside the output card, it only got the switch, so the external device must have a load. Okay, this external load has their own load. Load is something that has a resistance, such as buzzer, such as relay coil, contactor coil, okay, or any other things, okay, that has resistance. In this case, this is a contactor, which is has two parts. One part is a contactor coil, the other part is a contactor switch. Okay, this is a load. Okay, so it has a power supply, it has the load. Okay, it has the internal switch inside the PLC output card. Okay, so the PLC input card, whether it's a digital analog, will always take the signal from the external sensor or switch. Okay, such as in this case. So for the PLC output card, it will send the signal from the output card to the external load. Okay, for example, as for this input card, this switch or any other sensor will detect something, it will send a signal. Okay, so this signal may be in the form of current. Okay, it will flow through here and then to the PLC input load, and then to the common line and go back to the power supply. This is an example of PLC syncing. Okay, for the PLC output card, it will always send the output signal from the PLC output card to the external load, and it will energize the contactor coil in this case, and then will flow through this power supply and then back to this terminal. Okay, so this is another example of the PLC wiring circuit. So this is a start push button and this is a stop push button. Okay, which is an external instrument switch. Okay, that connected to the PLC input card. And then this output card is connected to the external load. You can see this is contactor. This is contactor internal coil, which is a load. This is a thermal overload relay. Okay, so when this start push button is pressed, so it will trigger the normally open contact, which is here, to close, and the current will flow through this to the through the switch, the push button switch, and then go into the PLC digital input card, and then it will go into the digital input load, and then will exit from the common terminal point and back to the neutral line. Okay, so this depending on how we write the PLC program, such as this program, the ladder logics. So the virtual point inside the PLC program may energize, and it will send the output signal through the terminal point of the digital output card to the external load, which is in this case is the contactor solenoid coil. Okay, and then it will go through this line to the auxiliary normally closed contact in this case, and then back to the common line, and then back to the neutral. Okay, so when the coil is energized, what happened is the three normally open contactor switch will trigger from normally open to close, and then the three-phase power supply will go through the contactor and the thermal overload relay, and then to the motor of the pump to start the pump. Okay, that's it. Thank you.